Welcome back to my channel. This time I came up with the new chapter Metals and Non-Metals. This is the part 1 of Metals and Non-Metals, and in this video we will learn about the physical properties of the metals. So let us start the learning. So the contents which we will going to cover in this video are introduction of metals, why do metals have luster, electron excitation, thermal and electrical conductivity in metals, electropositivity, sonority, malleability, and ductility. So let's start. So, how can we define metals? Metals are lustrous, malleable, and ductile. Metals possesses high density. Metals are solid except mercury, which is liquid at room temperature. Metals are generally hard except sodium and potassium. These can be cut with a knife. Metals are also good conductors of heat and electricity, and they have electropositive nature. So, metals have all these properties. We cannot define metal by single definition. Rather, we have to check whether all these properties are possible in a material or not. If a material or a compound possesses or have all such properties, more or less, then it can be considered as a metal. Now let us learn about all these properties one by one and check the details about it. So this is the first property and it is very important, luster or shine. Why do metals have luster? We know that electrons in metals are loosely held, hence they are known as mobile. Mobile here means that electron in a metal can move from one orbit to the another orbit, that is from one energy level to the another energy level. Thus the electron present in the metal absorb energy and get excited to the higher energy level. When these electrons come back to original energy level, they emit electromagnetic radiation. So this is the reason why metals have shine. They emit electromagnetic radiations. So let us see how. How this excitation of electrons takes place in a metal. For this we need to learn about the atomic energy levels. So let us consider this is an atom of a metal and it has two energy levels. Now you can see here the electrons are present in the first energy level. So when this electron absorbs energy, this is the energy which the electron is absorbing from the outside. By absorbing the energy, this electron jump from lower orbit to the higher orbit. So here you can see the transition of electron from lower energy level to the higher energy level. This process is known as atomic excitation or electron excitation. Now this electron which is present at higher energy level is unstable at this position. So what it do? It basically releases the amount of energy which is being absorbed. So it releases the equivalent amount of energy which is being absorbed and come back to its original position. So here you can see that electron at higher energy level come back to its original position by releasing the exactly same amount of energy which is being absorbed initially here. So this is known as electron excitation or the atomic excitation, and due to this metals have luster. Let us now talk about the thermal and electrical conductivity in the metals. We know that metals are good conductors of heat and electricity. So let us perform some activity to show the conduction in metal. In this activity, I am going to show you the thermal conductivity in metals. For this, we need to have such a setup which is shown in the figure, and we need to heat a metal rod. We can take any metal rod. Say we have taken copper or aluminium. This is the metal rod which has been taken, and this is heated with the help of burner. And this is the point of contact where the heating is initiated. Now to the free end of the metal rod, you can see here we have attached a wax with a pin. So when we start burning the metal, the heat will start flow from this point to the free end. And slowly through the process of conduction, the heat will flow from the hot part to the cold part of the rod. And finally it reaches to the wax. And wax will melt and the pin will fall down. This experiment shows that the heat is conducted from one place to the another place. Or we can say that the heat is transferred from the hot end of the rod to the cold end of the rod. So this is how the thermal conductivity takes place in a metal. Now what do you have to learn? You need to learn that silver is the metal which has the highest thermal conductivity. Now let us do one more activity to show that metals are good conductors of electricity as well. So for that we need to have such a setup in which we have to make a circuit. For that we have a battery, we need a switch and we need a bulb. To this circuit we have connected a metal which has to be tested for the conductivity. As soon as we switch on the battery, what happens? The current will start flow, and this current flow from this metal to the bulb, and finally the bulb will start glowing. So this activity tells us that the metal which is attached in the between helps in the conduction, or it helps to allow the flow of electrons from it. That is, it allows the electricity to flow through it, and this is the reason the circuit is complete and the bulb will glow. So through this activity it's clear that metals are good conductors of electricity as well. Again, here we need to learn that silver is the metal which is the best electrical conductor. Then it is followed by copper, gold and aluminium. So some facts you need to learn for exam purposes also. Now let us talk about the electropositivity. What is electropositivity? Metals are electropositive. Tendency of atom of an element to lose electron and to form positively charged ion is known as electropositivity. So it is the process by which metal lose its mobile electron and thus converted into the positively charged ion. A more electropositive metal will show more metallic character. So the metal which is highly reactive will show the electropositivity more. So every metallic atom has a tendency or has a specific tendency to behave as an electropositive. Different metal has different electropositivity strength. Now how we will going to know about it? So for that we need to learn the electrochemical series. In electrochemical series, the metals are arranged on the basis of their electropositive character. The metals which are placed upward are highly reactive. They are highly electropositive. For example, potassium, sodium, magnesium, aluminium. Whereas the metals which are present at the bottom of the series, they are inert. They have less electropositivity. For example, silver, gold and platinum. They are inert metal. And this is the reason they show corrosion very slowly, or they don't corrode. Whereas if we talk about the metals which are present at the top of the electrochemical series, they show corrosion very easily. They corrode easily. Why? Because they are highly reactive in nature. Also, you can see that the elements which are present in the top of the series are generally from group 1 and group 2 of the periodic table. That is, they are alkali metals or alkaline earth metals. So they have a valency of +1 and +2. So this is the reason they are highly electropositive. So by learning this series, you can check the electropositivity of the different metal and you can compare also. Now sonority and density. Sonority and density are the simple properties that metal exhibit. Sonority is the characteristic of a metal to emit deep resonant sound when stuck. Hence some are used for making bells. Density is defined as the mass of unit volume of a substance. Iridium is the metal with the highest density. Its density is of about 22.65 grams per centimeter cube. Here this 3 should become on the superscript. It is centimeter per cube. So this is all about the sonority and density. So metals are sonorous and they are highly dense. Now let us talk about the malleability and ductility. Malleability is the ability to be compressed. It is often characterized as the material's ability to form thin sheets when rolled. So here metals can be beaten into sheets and this can be used commercially. Similarly, ductility is another application. It is the ability to be stretched. It is often characterized as the material's ability to be pulled out into the wire. So all these properties are there because of which metals can be used commercially for many purposes. Now let us know where exactly in the periodic table do we see metals and non-metals. So this is the periodic table. Here you can see that extreme left side here, metals are present. Then extreme right side we can see non-metals. In between, transition metals are present. They show the transition in their characteristics from metals to non-metals. Now, if we look closely, this group 1 element, that is hydrogen, lithium, sodium, potassium, they are known as alkali metals. They have a valency of +1 and they are highly electropositive. Then group 2 elements, magnesium, beryllium, calcium, strontium, they have the valency of +2. So they are again highly electropositive. So in this chapter, you need to learn about these two groups only. Now, if we talk about the non-metals, then in this chapter, we will going to learn more about the group 17 elements and group 18 elements. Group 17 elements are known as halogens. They all are non-metals. Fluorine, chlorine, bromine, iodine, astatine. These are the non-metals and they also have a valency of 1 but -1. Hence, they are highly electronegative. If we talk about group 18 elements, then these group 18 elements are inert in nature because their octet are complete. So they do not undergo a reaction easily. Any chemical change easily. So this is all about the periodic table. You should know the position of position of metals and non-metals in the periodic table. So in periodic table, metals are present towards the left side, whereas non-metals are present towards the right side. Now, what are the learning from this video? Now, I think we can able to solve these questions. Let us try. Why are metals good conductors of electricity? Because metals have free electrons and these electrons are mobile in nature and they can move from one orbit to another orbit. Why metals are electropositive? Metals are electropositive because they have a tendency to lose or to donate their electron. Also, the metals which have the valency 1 and 2, they are highly electropositive and they have a tendency to donate electron easily. Hence, they are electropositive. By donating the electron, they are converted into positively charged cation. Now, question number 3. Aluminium and copper wire required for electric circuit coated with a rubber-like material. Why? The reason being that aluminium and copper both are metals. And metals are the good conductors of electricity. So, if they are used for the conduction of electricity, they need to be covered with an insulator to prevent the external shocking. Hence, they are covered with the rubber-like material. Now, how can we use metals commercially? As we know that metals are good conductors, so we can use commercially for the conduction of electricity. As we know that metals are malleable, so we can use them for making sheets. As we know that metals are ductile, we can use them commercially for making wires. So metals can be used commercially for many purposes. Now the last question, why metals are lustrous? Why metals have luster? This is due to the electron excitation property in a metal. Metal can show the electron excitement by the absorption of the energy. And when this electron come back to the ground state level, it emits the electromagnetic radiation. And thus metal have luster and they shine. So these were the learning from this video. Hope you all liked it. Thank you.